I really mean. So that's it. No, there's like a meme where everyone's like, oh, there's like a billion imperfects in this. And there's like but then the bullshit question I knew I got wrong. I've never seen a question with these standard chosen. That's easy. I know it is easy, but literally you can get either or, depending on how you make your G-Rock and volume. Depending on how you do it, you could either get H plus on the left or the right side. But I know for a fact coefficient is one. I can't believe this is the reason I lost my streak.
It's okay. It's just you're not even taking the favorite.
And you.
Great. Great.
Tomato juice low.
I heard D is one.
Why did you even read that? The phone was low. Just put it on.
Yeah, I just typed it over. I do
Fine. I think I know all the way.
I don't know.
You hate yourself? Can't hear you. So. I'm using on this one. This is not a favorite thing. That's the number one rule if you don't know. If you get hard, don't open your mouth. You know, I got my answer. That was correct. I just had been counting. The answer was pretty decisive. That's what I got off.
That's nice. Wait, how? What type of faults like this?
It was like it was an easy problem too. It was just like it gave you delta H and it gave you delta S. Oh, just like what temperature does it become spontaneous? It's like I know how to do that. So yeah, and then I got it wrong. I made the stupidest mistake. Every time. Why do you have all that? Stuff.
Oh, hell no.
Oh, I never. I actually figured out.
The moment is like,
It's a bit better.
we have to do more. Oh my God, it's all about.
Get the problem there.
Yeah, and that can be kind of really. Wait, why are you thinking?
Okay, so any questions before we get started? So on Teams, I have summarized the things to help you prepare your final. So I create a post to reorganize the hangout you need, and then the video you can watch. So that those are the things you have to go over. Okay. And we will have, I also make an assignment this morning saying that if you have some calculation errors, okay, for example, you forgot to convert carbon to C, okay, feel free to submit those respond to the assignment, okay, so you can get some project credit back. Okay. And this thing will due on Sunday. Okay, so make sure you actually do it as soon as possible. Okay, and I will encourage everybody to use the resource here to prepare your final. I know everybody's busy, so I think this will be the very last thing I can do for you. Okay, so today will be the very last lecture of this semester, and we'll go through a few, I think 11 questions. Hopefully, we'll have enough time to finish those 11 questions. And this question, I think, is actually a good representative of the things you want to actually really know from the midterm 1 to midterm, midterm 3, I think. Yeah, but I think these videos that we record and share before, I think it's a really good resource. Okay, so if you go back to understand how to do all the questions in the review videos, you should have actually a very good understanding about what you are going to encounter for your final. All right. So any questions before we get started? Okay, for now, now what's this? Question number 1. Okay, so this says the lanthanum chloride dissolved in water following this equation. What's the boiling point of the solution when 0.2453 gram of lanthanum chloride is dissolved in 10 gram of H2O? And they give you the Kb of H2O. Okay. So keywords. What's the keyword here? Yes. So this actually go back all the way back to the chapter 10. Chapter 10 or 12, I forgot. Okay, the very first chapter we went through for this semester, right? The collective property. Okay, so that is actually a very big part of that chapter, so make sure you know how to do those calculations. Okay, so we kind of review the things on Tuesday about equations, right? So one of the equations that I tell you to memorize this. Right. The boiling point elevation, the degree of elevation can be calculated through this simple equation, right? The change of your boiling point is going to equal to vapor coefficient I times the Kb times the molality. Okay. So once you have this idea, the next thing is actually trying to find out these informations, right? And then apparently you have the Kb here already, right? That means if you figure out your I, you figure out your molality, then you can figure out your delta Tb. Once you figure out your delta Tb plus 100, there will be the new boiling point. Okay, so let's the logic flow here. Okay, what's the I? 4, right? So by now you should actually see these things very clearly. Okay, one solute is going to produce 4 particles. Right, there the I is equal. Okay, the force is coming from the coefficient sum of these two, right? 1 plus 3, that give you 4. Therefore, this is actually how you get the information of 4. Okay. KB is 0.512. Then molarity, right? The definition of molarity is mole of your solute divided by the mass of your solvent in kilogram, right? So here it tells you you have left many gram. Okay, so to calculate the mole, you use 0.252453 divided by the formula weight 245.3. Okay, that's how many moles that you have. The mass of your solvent, 10 gram of water, right? Therefore, this is 10 gram of water converted to kilogram, you divide it by 1,000. Okay, so if you do let things, put everything in, then you can get your TB change will be 0.205. Okay, therefore, you know your final boiling point will be 100 plus 0.205. Okay. The reason you know you have to plus is because in the closing policy, the boiling point will always increase when you add in more solute. Okay, so it will be plus. Therefore, you're going to get the answer 100.205 degrees C. Okay. So let's do this one questions in the midterm one review video. Okay, so if you don't have a good grasp of this concept, go back to the review videos, then you'll actually understand more about this topic. Okay, but let's actually our first questions. Okay. Question number 2. Calculate the molarity, which is your big N, right, of an aqueous solution that has 23% by mass calcium chloride. Okay. And then it tells you the density of that solution is 1.2 gram per ml. Okay. So it's actually a very standard concentration conversion type of questions, right? So you have two concentration terms. One is molarity. The other one is mass percent. Okay, so I want to go from mass percent to molarity. And it give you the information of density. Okay. So very standard type of questions for midterm one. Okay. And then the things I want to emphasize is that if you see a concentration conversion into molarity, the capital N, okay, you will use the density information. Okay, so this one will be used. Okay, so how do you do this? First, from the definition, right? So you start from your mass percent, which was defined as mass of your solute divided by the sum of the solute and the solvent times 100%. Right? So let's actually definition of the mass percent. So every time when we do the concentration conversion type questions, we always need to assume, we need to actually always give some proper assumptions, right? And the assumption idea is that make the denominator either equal to 1 or 100, right? So since it's actually a mass percent, it's percent, so therefore we assume the mass of the solute plus the mass of the solvent equals to 100 gram, right? So that's the assumption that you will need to make first. So once you make that assumption, then you will know the mass of your solute will equals to, this is 22.3 gram, right? Because that is actually the concentration given, right? You have 22.3% of the solute. So your solute is actually calcium chloride. Then the mass of solvent will equals to simply 100 minus 22.3. That's 77.7 grams. Okay, so let's actually the mass of your solvent. Okay, so once you actually finish this, the next thing is actually you go back and look into what do you need to solve your molarity, right? The definition of molarity is mole of your solute divided by the volume of your solution. And the mole of solute can be calculated by the mass of your solute divided by its formula weight. Okay. The volume of your solution, okay, we will need to actually use the equation that density equals to mass of your solution divided by the volume of your solution, right? So you can rearrange this one to solve that the volume of the solution will equals to the mass of your solution divided by the density. Okay. So these are the two things that you will need to actually solve. So this will be the mass of your solution divided by the density. Okay, so from your assumption that you know the mass of your solute is 22.3 grams. Okay. The formula weight of calcium chloride. Okay, so you need to check your periodic table, okay? But if you check it, you are going to see the formula weight is 110.98. Therefore, you divide 110.98 here. So you can get moles of your solute, okay? The mass of your solution will simply be the mass of solute plus solvent, right? So let's actually 100. Divided by the density, 1.2. So once you do this, you got the volume, but the volume has a unit of milliliters. Therefore, you need to actually further divide this number by 1,000 to convert it into liters. Okay, so once you do all this operation, then you will get the final number of 2.4 molarity, and there will be the answer you're looking for. So this is actually the logic for how you can solve this type of questions. Okay, starting from the known concentration, make a proper assumption, and then based on the target concentration definition, to find out the necessary terms. Okay, so there will be the basic logic for this concentration conversion type of questions. Okay, any questions? Good. Next. Okay, so those are the two questions I picked for the first chapter. Right? Second chapter is about the kinetics. Okay, so one of the things that we need to actually know is how to write out the rate law from the elementary step, right? So this is actually a very typical and standard type of questions that you probably will see for that chapter. Okay, so it says the proposed mechanism of a reaction involves these three steps. A plus B give you X, X plus B give you Y, Y then converted to C. And then the first step is actually the slowest step. Okay, and actually what is actually the possible rate law? Okay, so this one is actually a multiple choice question. Okay, so I just you will give you okay the rate law equal to K times whatever C is to whatever power. Okay, and the one I showed there is actually the final answer, right? But the things I want to demonstrate here is actually tell you what is actually the logical step to figure out the correct rate law, right? So the first step is that you need to find out who are your reactant, who are your product, right? So the way you figure out that is what? You add up all the elementary steps. Okay, so once you add up, you will see that that will cancel out. This and that will cancel out, right? So the X and Y is our, what is X and Y? Intermediate, right? Because they actually show up first time on the product side, right? We mentioned that if the things cancel out, but its first appearance, if it's actually on the reactant side, that species will be the catalyst. Okay, I'm just trying to remind you what are the things you may actually see. Okay. So, but back to this, right? If you actually write out all this, then you'll see the overall equation is this. Right? A plus 2B that give you C. That's the overall reaction. Therefore, you know your reactant only contains A and B. Therefore, your red law must follow this form. Right? So let's count the setup that you should have from very beginning. Okay. So within this multiple choice, okay, if you see anything contain X, they won't be your answer, right? Because they are not the reactant. So you can cross those out immediately. Okay. But how to actually find the right one is actually you want to go to the slowest step, right? Because that will be your rate limiting step. Then write out the rate law from there. The rate is equals to K as your A as your B, right? So the beauty of this elementary step is that you can write out the rate law based on the coefficient of your elementary step. So you have 1A and 1B in the first step. Therefore, you can just write out your rate law equal K times A first power B first power. Okay, so after you write this out, then you start to check. Okay, so once you write it down, then you start to check. The things I use to write out the rate law belong to the reactant. Okay, as long as the things you write out belong to a reactant, you are fine. Okay, so in this case, yes, it is actually all your reactants, right? Then you're done. Okay, so one thing you want to also know is that it doesn't have to contain all the reactants. Okay, as long as the inside the equation, all you have, they are part of your reactant, then that's good enough. Okay, so for example, if today I rewrite this, the first step is A becoming X. Okay, and this is actually my slow step. Okay, then follow the same philosophy, then you will be able to write the rate equals to K times A to the first power, right? And this one is fine too, because all you have in the equation contains only your reactant. Okay, so let's count the basic ideas that we must have for the elementary step. Okay, how to actually construct the results from the elementary step is actually a big thing for this chapter. Okay, any questions for this? Why didn't I add a square? Because in your elementary step, you only have 1B. Therefore, you only have one overlayer. Okay, so that's actually a big difference of the overall reaction, right? Because you can never write out the rate law based on the overall reaction. You can only write out the rate law based on the slowest rate limiting step. Okay, so in this case, will be your step number 1. Thanks. Any other questions? Okay, so if not, then move on. Okay, so this is actually one of the figures you need to be very, very certain. Okay. So I'm going to ask you a lot of questions, okay? But first thing first, okay? It asks you, is this reaction endothermic or exothermic? Exothermic, how do you know it's exothermic? Yes, you use the energy of your A and E to calculate that, right? So it's always the product of minus reactant, right? Since your product has low in energy, therefore when you actually minus the energy of your reaction, you have a negative value, right? Negative value is exothermic. Okay? Next things, since you know it's exothermic, here to here will be your delta H, right? It's exothermic, therefore your delta H will be negative. All right. Next question. Where is your activation energy? The activation energy will be what? There'll be your EA, right? The highest peak to reference to your reactant. That's your activation energy. Okay? Everybody done with this? Okay, the next things I want to know is how many intermediate? Two intermediate, right? So how do you find out the number of intermediate is that you find out, one intermediate only. So one intermediate, okay? What's this? What's B and D? So B and D is called a transition state. Okay, so two transition states. Okay. So how many steps is actually this reaction? So the number of steps will equal to the number of transition states. Okay. So this got two transition steps, therefore this will be a two-step reaction. Okay. Everybody fine with this? We good? The next thing I want to ask you is that okay, so if today I have this, okay, if that is actually the figure you have in your exam, is this reaction exothermic or endothermic? Endothermic, how many steps? 5 steps. Okay, you see five, what do you call this? Pump. Okay. And then you should really know how many intermediate you have, right? And how to calculate your delta H. How do you define your EA? Okay, so those are the things that you will need to know. Okay. After that, then we start to talk about the equilibrium. Okay. Then we start to learn about the pH calculations. Okay. So here I do not pick up too many pH calculation examples because that will take too much time. That I don't think I can finish all the questions today. Okay. So for the midterm 2, really go back and rewatch the midterm 2 review videos. Okay, but I think we have good understanding of that part. Okay, so do come go back and rewatch it. I only want to actually point out one of the example here. Okay, which is actually probably actually the most complicated case in the titration problem for the pH calculation problem. Okay. So let's read these questions. It says, calculate pH of a solution prepared by adding 20 ml of 0.1 m HCl, 80 ml into 80 ml of buffer that comprise of 0.25 m NH3 and 0.25 m NH4Cl. Okay. So, and they give you the KB for this. Okay. So the idea is actually, I don't really care what kind of acid base that I have. I don't care it's strong or weak, right? So I would like to translate this one into I have a 0.1 m strong acid, right? So I will use H plus to represent my strong acid, right? And then comprised of amine, right? Amine apparently is actually my weak base. I use A minus to represent the weak base. This is actually the weak acid, that's your HA, right? So every time when you try to do the calculation of the pH, right, we will need to use moles or molarities, okay? So let's write out the things that we know for now. The data that you have is for your strong acid, you have 0.1 m, 20 milliliters. Therefore, you know you have 0.1 times 20, that's 2 millimole of strong acid, okay? Weak acid HA, you have 0.25 m. You have 80 milliliters. Therefore, you have 0.25 times 80. That's 20 millimoles. Okay. For your weak base, A minus, you have the same concentration, the same volume. Therefore, you also have 20 millimoles, right? So those are the things that you have from your data, okay? And then the next thing is actually you want to know, this is actually the initial condition that you have, but in order to calculate your pH, you will need to find out the concentration at equilibrium. Okay, so to get that, then we use H plus A minus, that give you HA. Then we know in the beginning you have 2 millimole, 20 millimole, 20 millimole. Okay, and we say the strong acid and strong base, they are the dictator, right? They don't kill everybody, okay, unless they got killed first. Okay, in this case, apparently you have less amount of strong acid or strong base, therefore it will be fully consumed. And then at the same time, you're going to produce is the conjugated acid of your weak base. Therefore, when you reach equilibrium, you don't have any strong acid anymore, but you do have 18 millimole of weak base, but 22 millimole of your strong acid, right? Then you start to analyze the situation that you have. Okay. In your solution right now, you only have your weak base, and it's conjugated acid. Therefore, you're going to have a buffer solution, right? So since you have a buffer solution, then you can calculate pH using HH equation, which is pKa negative log your weak acid over weak base concentration, right? So apparently in this case, you don't have Ka, but you do have Kb. 1.8 times 10 to the negative 5, right? So you want to actually convert the KB into Ka. The way you convert it is actually you can calculate your Ka from Kw over your Kb. Kw is actually 10 to the negative 14. Your Kb is 1.8 times 10 to the negative 5. Okay, so this is actually how you get your Ka. Okay, so once you do that, this will be negative log 10 to the negative 14 divided by 1.8 times 10 to the negative 9. Negative 9 or negative 5. Negative 5. Okay, and then negative log, right now the equilibrium acid is 22, base is 18. Okay, so once you do the calculation, you'll get 9.26 for your first term. Second term will be 0.09. Then get your final pH of 9.17. Okay. So this is actually how you solve this pH type of calculations, right? Okay, so this is actually how you handle these problems. Any questions? Okay. Next. After this, then we start to talk about the KSP. Okay, so the KSP question is actually very standard, right? It always asks you to compare your QSP, compare your Q to your KSP. Okay, basic idea is Q larger than KSP, precipitate will form. Okay, and Q smaller than KSP, not precipitate. Okay, so let's enter the basic idea, right? So let's read this question. It says the KSP of AgCl is a certain number. Consider solution contains A, solution B, and ask you whether the precipitate will form, right? So every time you encounter this one, you must have an idea that the two solutions, okay, each of them will contain part of your solute particle in your KSP equation, okay? So KSP equation for this case is AgCl solid will dissolve become Ag plus and then the Cl minus. Okay, and the KSP is Ag plus concentration times your Cl minus concentration equals to 1.6 times 10 to the negative 10. Okay. So let's actually the first thing that you need to write out when you encounter the KSP question. Okay. So the next thing is that you are given two solutions, okay, and each of them will contain, one will contain H plus, one will contain Cl minus, okay? So you want to look into this. If you look at this, the CaCl2 apparently contain the things of Cl minus, right? Therefore, you want to get the Cl minus concentration from here. These things will be a soluble salt, means it's going to dissociate 100%. Okay, the things that's going to be careful is that. Okay, you need to see that for your CaCl2, one equivalent level is going to produce two equivalent of Cl minus, right? Therefore, you have to put 2 times 1.0 times 10 to the negative 2. You have less many Cl minus coming from the CaCl2. Okay. Apparently, the other one will provide you the Ag, right? So since this coefficient is only 1, therefore you know your Ag concentration will be 1 times 10 to the negative 8. Okay? Therefore, your Q, which is also going to equals to your Ag plus times your Cl minus, is going to equals to 1 times 10 to the negative 8 times 2 times 10 to the negative 2. They will give you 2 times 10 to the negative 10. Okay. Then you compare your QSP and KSP. Apparently, this is 2, right? That's 1.6. Therefore, your QSP is going to be larger than your KSP. Therefore, precipitate will form. Okay. So this is actually something that is actually a very simple question. It really tests. Can you see the Cl concentration is 2 times of the given concentration over there? So pay attention to the subscript of that chemical formula. Okay, any question for this? Okay, if not, then I think there's actually one more of this. Okay, so this is actually the common ion effects for the KSP. Okay, so the question is that the KSP of AgCl is 1.6 times 10 to the 10. What is the solubility of AgCl in 0.001 M and GCl2? Okay, so again, write out the equation first. Okay, so let's actually the equation you want to write out first. Okay, then you start to look into this. Okay, so whatever species of fine layer, it must generate the ionic species for the AgCl, right? Either Ag plus or Cl minus, right? And here you see is MgCl2, right? That means actually this one is going to produce your Cl minus concentration, right? And the concentration will be 2 times 0.001. You're going to produce that much Cl minus from your MgCl2. Okay. Then you want to calculate the solubility of this guy, right? Therefore, you know, once it dissolves, you're going to have S, Ag plus, and then S, Cl minus. Okay, so at equilibrium, there will be the condition that you're going to have. Therefore, you want to use this one to calculate your KSP, right? It will be S times 0.002 times your plus your S. Okay. So one thing that you need to always know is that in the KSP calculations, we're always going to use the small s approximation, meaning that your S will be so small, therefore this term will basically equals to this. Okay, so you can simplify this. It becomes 0.002 times your S. And this will equals to 1.6 times 10 to the negative 10. Therefore, your S will equals to 1.6 times 10 to the negative 10 divided by 0.002. Therefore, you'll come up to this solubility answer. Okay, A times 10 to the negative 8. Okay, so this again is a common ion effect for the KSP calculations. Okay, we also went through these questions in the midterm 2 review. Okay. All right. Any questions for this? Yes. Divided by 2 times 0.001. Okay, so that is actually coming from, do you see that this is that highlight the questions? It says inside the specific solution where you contain the MgCl2. Okay, so if you did not say the KSP of certain species, you can assume that salt is 100% dissociation salt, right? That means actually MgCl2 is going to dissociate 100%. Concentration of your MgCl2 is 0.001. But one of them is going to give you 2 equivalent of Cl minus. right? Therefore, you're going to have 0.01 times 2 that much Cl minus in that solution already. That's why I write that 2 times 0.01. Okay, so these actual kind of things are still always get confused. Okay, so when you put multiple things together, okay, and you need to actually consider the contribution from other species as well. Okay, it is not AgCl alone. It's AgCl put into a solution contain other species, and this species will generate a common ion, in this case Cl minus, in your solution. Therefore, when you consider the solubility of the AgCl, the existing Cl minus concentration needs to be taken into account. Very good. Okay. Any other questions? Okay, if not, next. Okay, so now we come to chapter 16. Okay. So this asks you for a reaction 2H2 plus Fe2O3 become 2Fe plus 3H2O. The delta G naught is 53 kilojoules and delta H naught is 100 kilojoules. Which of the following is completely true about the relationship between the delta G and T for this reaction? Okay, so this is actually a very standard question for chapter 16. Okay, but you should be very familiar with since you just finished your midterm 3. Okay, so how to actually solve this? The first thing is actually, since you have your delta G naught, you have your delta H naught, then you should be able to solve your delta S naught, right? So we know delta G naught equals to delta H naught minus T delta S naught. Okay, since it's all at the standard condition, the temperature will be 298, right? Delta G naught is 53 kilojoules, so I multiply 1,000. Delta H naught is 100 kilojoule minus 298 times your delta S naught. Okay, so by doing this, you should be able to calculate your delta S naught equals to 158 joules per mole. Okay. Then you want to find out the temperature. So here it is asking you, okay, you want to know delta G now. Okay. And then predict how the temperature is going to influence your delta G. Okay. So the things, every time we're trying to understand the effect of temperature on your delta G, okay, the first is actually want to find out the temperature at equilibrium, right? Because if your delta G is negative, move to the product, positive, move to the reactant, right? But you need to actually first figure out what's the temperature at equilibrium first, right? And we know at equilibrium, your delta G will equals to 0, right? Therefore, you can write 0 equals to your delta H minus T delta S. Okay, so your delta H is 100 kilojoule, right? Times 1,000 minus the temperature you want to find out at what temperature you are actually at equilibrium. Okay, your delta S is 158. Okay, therefore you can find a temperature of 33. Okay, so you know at 633 K, your system will be at equilibrium. Okay. So now you want to actually go back to here to think about this relationship. Your delta H is positive. Okay, it's 100 K, right? So your delta H is positive. Your delta S is also positive, which together with this negative sign will make the second term overall negative. Okay, so at 633, this delta H and negative T delta S term, they're actually the same, but in opposite sign. They cancel out each other. That's why you get the 0. Right. But if today you have a higher temperature, the higher temperature will make your second term dominate. Okay, so if your second term dominates, then your delta G will become negative, right? Therefore, you know at high temperature, your delta G will become negative. Okay. On the flip side, you also say at a low temperature, your delta G will become positive. Okay, so those are the statements you're actually looking for. Okay, and if you read the questions, you will figure out there is actually only correct statement among the four. Okay, because you know if you actually go above 633, your delta G will be negative, right? And then that's why we choose this guy. Okay, and all the others will be a wrong statement if you analyze the sign of your delta G based on the temperature that were given inside the question. Okay, so this is actually how you solve a question like this. Any questions? Yes, so we calculate 633, right? So it did not actually use 633. Instead, it's 635, which is already above that equilibrium temperature, right? So if you actually have a temperature higher than that temperature, right? It actually says larger than that temperature, right? You go even higher, which will make your second term dominate even more, which will make your energy even negative. Yeah, so it will be actually still a correct thing. Okay, so that's how we solve question number 8. Question number 9. Okay, so we enter chapter 17 now. Consider a galvanic cell. Okay, keyword again, galvanic cell. Built from the following half reactions with the standard reduction potential. What is the delta G for this reaction? Okay, so apparently galvanic cell is the keyword, right? And then you calculate delta G. Apparently you want to calculate your delta G naught from your E naught cell, right? So there will be actually the equation that comes to your mind. Okay. So which one should you flip? We know for the galvanic cell, the E naught cell has to be positive, right? Therefore, you need to flip one and add up the two potentials, the E naught up and then the E naught reduction, and it has to be positive. Okay. So with that consideration, you know, you need to flip this guy, right? So it will be negative 1.2 plus, so your E naught cell should be negative 1.2 plus 1.75, which will give you 0.55 volt. Okay, so that will be actually your E naught cell. Okay. So apparently this one will be 0.55. This guy will be 96485. If you figure out your N, then you're done, right? So how many electrons will be transferred between the two half reaction, right? So you can see this one is give out 6 electrons, one give out one take 2 electrons, right? So the basic idea is that the electron generated by your LoRa needs to be the same as the electron received by your G-Rock, right? So you know you can actually, since you flip this one, right? So this one will be your LoRa. This one will be your G-Rock. Okay. So what you need to do in order to get the final equation, right? You need to use one LoRa plus 3 times of G-Rock. Okay, therefore you know the total electron transfer between the two half reaction will be 6. Okay. Therefore you know this will be 6. Okay, so if you do the calculation, your delta G now will simply equals to -6 times 96485 times 0.55, and they will give you the value of -3.18 times 1,000 joules. Okay, so this is actually how you solve these questions. Okay, next. Consider the following system at equilibrium at 25 degrees C. PCl5 becomes PCl3 plus CO2, for which delta G naught is -92.5. What will happen to the ratio of partial pressure of PCl5 to Cl2 if the temperature is raised? Okay, so again, this is actually chapter 16 questions, right? So equation-wise, PCl5 become PCl3 plus Cl2, all in gas phase, right? So from this equation, one thing you probably want to know is that what's the sign of your delta S? Is your delta S positive or negative? You should know that your delta S is positive, right? Because you only have one gas molecule on your reactant side, but two on the product side. Okay, so the number of gas molecule increase, right? So your delta S is actually positive. Okay. And then your delta G, delta G naught is -92.5 kilojoules, right? I don't really care about the number, but I need to know the sign, right? Your delta G is negative. Okay. So if you put into this thing to think about this, okay. We know that delta S is positive, right? In combined with that negative sign, you know your second term overall, it is negative. Okay. And then it also tells you at the standard conditions, this guy is also negative. Okay, that means actually at 298 K, okay, your delta G is already negative. That means your second term already outweighs your delta H, right? So we know at 298 K, your negative T delta S outweighs delta H, right, which is negative. We don't really know the sign of your delta H, but we do know that negative delta S will create larger negative values. Okay. They will actually overcome your delta H. So once we have those ideas, and it says when the temperature is raised, okay, so once you increase the temperature, they will actually make your second term even bigger, right? Meaning that your second term will dominate the whole thing. Since the second term is negative, therefore your delta G will be even more negative. Okay, since your delta G is even more negative, that means actually you're going to have more product to form. Okay, so when temperature raised, delta G is more negative, meaning that you're going to have more product. Okay, so those are the things that you should have in mind first. Once you have these things in mind, then you go back and reread the questions. He asks you, what will happen to the ratio of partial pressure of PCl5 to PCl2? Meaning the PCl5 over P over Cl2, right? How this ratio is going to change. Then you look at this, PCl5 is your reactant. Cl2 is your product, right? It's reactant over product ratio. Since your delta G is even more negative, therefore this ratio is going to decrease. Okay, so that's how you actually come to this. All right, so that's the question number 10. Any questions? Good. Okay. Very last questions. PB210 decays to produce mercury 206 with half-life of 22.3 years. Starting with 7.5 gram of PB210, how many grams of Hg206 will present after 17.5 years? Okay, so this is actually very standard decay problems, right? And then you should know the decay happen in this way. Okay. Keyword here, of course, half-life. Okay, so starting from half-life, we should actually you must be very familiar with this now. K times T half is going to equals to 0.693. Okay, so T half is 22.3. Therefore, you know your K is 0.693 over 22.3. It's going to give you a value of 3.1 times 10 to the negative 2, okay, per years. Okay, so that's the K you're going to use. Okay. Then he asks you if you have 7.5 gram of PB to start with, right? Starting from lead, right? So this one will be your A0. Okay. And then you want to know how many of lead. So how many of lead will remain after 17.5 years? Okay. Therefore, you want to actually calculate your AT from here. Okay. Therefore, we know the way you calculate it is we want to know how many of PB210 will remain, right? But you can use grain, you want to use moles. So you divide by its formula weight, 210. That's your AT, right? A0 will be 7.5 divided by 210. And then this will equal to negative K, 3.1 times 10 to the negative 2. T, 17.5 years, right? So by solving this, you're going to get the X. Okay, so your X will equals to 4.35. Okay, so you get 4.35 gram. Okay, this is actually remaining PB210, right? So you still have PB210 of 4.35 gram. Okay, here is actually the part that's actually very interesting, and you need to be careful because inside this question, if you reread this, okay, starting with the sample of 7.5 gram of PB210, how many gram of Hg206? It is not asking your PP210, but asking your mercury. Okay, it asks how many mercury will present, right? So how do you actually figure out that? Okay, So mercury is what? Mercury is actually the decayed product, right? You're going from the Pb become mercury. Okay, so during this decay, what's going to happen is going to your Pb is going to undergo radioactive decay. Okay, some of the energy will be released from those emissions. Okay, from those decays. Okay, but the things you can know for sure is that one Pb, once it decays, is going to produce one mercury, right? So if you know how many Pb was decayed, okay, then then you will know that how many mercury will be formed. Okay, once you know that amount, you multiply the formula weight of your mercury, will give you the mass of the mercury. Okay, so how many Pb is decayed? Okay, it will be, you start from 7.5, you minus 4.35. Therefore, you know you are going to get 3.15 grams of Pb210. You have that many Pb210 decayed. Okay, so exactly how many in numbers, not in mass, right? You know you can do, that's how many more of Pb210 got decayed. That means that's how many moles of 206 will form, right? So this is actually the mole of Hg206, right? To know the mass of lead, you just need to multiply its formula weight, okay, which is 206. Therefore, you get the final answer, 3.09 grams. Okay, so here is actually a part that a little bit trickier because it is not asking about Pb, but asking about the mercury, right? And then this mass between these two is actually slightly different because part of mass will undergo this decay and eliminate a lot of energy, right? In exchange, some mass defects. Okay, so this is actually how you get to that 3.09 grand answers. Okay, so if you just do a simple subtraction, what you're going to get is actually how many grams of Pb has decayed. But it doesn't, they will not equals to the mass of your mercury 206. Okay, so make sure you actually see that differences. Okay, in order to actually really get the mass of your mercury, first to calculate the mole of your mercury. Okay, which will equals to mole of Pb that got decayed. Okay, then you multiply the mass of your mercury. Therefore, you can be able to get the correct answer here. All right. So this will be the very last questions that I want to go through today. Okay, but before you leave, before the end of this semester, I want to say something. Okay, so first, thanks to work with me. Yeah, people show up at the very last lecture. I truly appreciate your effort. Okay, and I hope that I've demonstrated you that I care about my students. Okay, you can see I put in a lot of effort trying to put all the material together for you to hopefully will make you feel chemistry is not that bad. Okay, if you learn the chemistry in the right way, I think it can be very interesting. Okay, but more importantly is that regardless the content of this course, I hope that I demonstrate you and let you know how you can actually prepare yourself better. Okay, I talk about a lot of things about this outside the study material, right? I tell you, okay, how you should actually start to think about your future. Okay, you're actually in a very unique timing of human history. Okay, so it's very like the first time we have this the industry revolution, okay, which is around 200 years ago. That's the time. I see those things actually start to happening again now. Okay, with this invention of AI is just too crazy. Okay, so I do feel like the way we study will change quite a bit. Okay, with the great help from the AI. Okay, so you need to think about what is actually things you can actually work with AI. Okay, everybody have different goal. I understand that. Okay, but that's not something you can just ignore because you will happen. Okay, so despite these changes, right, there's still a few things that we can always do. For example, the way we grasp the knowledge, right? How can we actually make ourselves more efficient to understand things, right? So you need to find out your own way. Okay, so in this lectures, trying to demonstrate to you is that the way I internalize all this knowledge is by making note, right? And I try to eliminate all the unnecessary information. Okay, I keep the things I need to memorize very, very minimum. Okay, but it's not easy. It's only after you fully understand what you want to understand, then you can start to distinguish the important from the non-important. Okay, and I think that's actually a very important skill set that you will need. Okay, I think one of the video I watched recently talking about the development of AI, okay, from Jensen Huang, the CEO of NVIDIA. Okay, one thing he said I think resonates me very well is that in the future, the knowledge that we learn, okay, AI can do a better job. Okay, so then what's our advantage? Is that we need to actually have a good taste in making right decision. You will need to actually do that when the situation is still unclear. Okay, so why that is important is because the AI will be super strong and outcompete all of us when the things they are clear. They follow rules, right? So if they can see a clear pathway, they will do a better job than us. The only thing they cannot do is that, okay, when the things is actually not very clear, when the rule is actually not clear, human always perform much better than AI, always. Okay, that means actually we still don't know what's the actual magic power that humans still have, but we do absolutely well things. Okay, and sometimes people call this as your intuition. Okay, but I do believe those intuition coming from actually very standard things, right? When we study any object, okay, how to actually summarize the information and seeing the information behind the lines. Okay. We infer a lot, like human actually infer from the message we got a lot. Okay. It's so much that the AI still cannot replicate that. Okay, so you need to actually somehow make that ability strengthen through your study. Okay. I always think that human, we digest the information and convert it into knowledge. It always takes time. Okay. But I think it's because those time allow us to reorganize, reshuffle all the information that we got to a level that starts to make sense to us. Okay. Then we use those make sense information to do what we want to do in the future. Okay. You actually purchase that a lot more in the future. I mean, the more you practice, I think you actually make it more competitive to the next level to do. Okay, so I think those are all very important informations. Okay, which those are the information I think even more important than the content of this lecture. I want to really think about what you want to do in the future. Okay, so you're actually entering pretty much, you're going to enter the golden age of your life now. Okay, you'll be most physically capable, mentally capable. Okay, and you become one of the most knowledge person in your generation. Okay, and you should actually use your time to maximize those capabilities. Okay. And the only reason you want to do that is because once you have low things, you put yourself in a much better position to complete the things they want to complete. Okay, so I wish like every of you have a wonderful life and can really fulfill your dream. Okay, but all these things takes time, takes efforts. Okay, and there's actually no shortcut for success. Okay, so you need to actually need to work. Okay, have a plan. Okay, to have a plan, the first thing is actually you have a goal. Okay, so really know what you want. Okay, start to write out these planning things. I think it's actually very important at your stage. Okay, and if you find someone in your life, you feel like, wow, this professor or this person really inspired me. Okay, if that guy is willing to talk to you, then there will be actually a wonderful, wonderful resource for your life. You are not going to encounter many of those people in your life. Okay, you want to encounter those people at the right time. Okay, and then really listen to that, and then take action to make it work. Okay, so those are the things I want my students to know. Okay, so that by doing so, I think you have a better chance to really eventually get into your dream. Okay, so those are my personal opinion. Again, personal experience. Right. I do encounter a few people like that, my PhD advisor, my postdoc advisor. Okay, and when we come to here, some of my senior colleagues, they all provide me very valuable information. Okay. One thing that I feel like humans are afraid of, but I think such a beneficial is that reaching out for criticism. Okay. You should have a strong mindset so you can improve. And the way to improve is actually you know what you are short of. Okay, you need to know what you're actually lacking. So you don't need people who always say good things to you. You want to become friends to those people who criticize you all the time. Okay, of course the criticism has to be constructive. Okay, it's just like personal insultation, that's not the person I'm talking about. What I'm talking about is actually they're not afraid to let you know that, oh, I feel like this is actually not so great. And they give you the reason. And they also provide you a property improvement. Those will be very, very valuable resource for your life. Okay, if you encounter people like that, you will appreciate their efforts. Okay, so at the end of this semester, I think I will need some of your help. Is that I guess I talk a lot about things outside the lectures. Okay, somehow I become more and more popular in our department for teaching the CHEM1312. Okay, but I wish that the student can actually listen to me and really follow the lead from the beginning of the semester. Okay, which I found it very difficult, and I understand why. People doesn't actually listen to me simply because they don't know me. Right. So I have so many students who actually come to me after midterm 2. They say, okay, Dr. Chen, I just realized that I should have talked to you earlier, listen to you earlier, right? But it's too late. Okay, many of students, I feel sorry for them, but there's really not much that I can do with the time after past midterm 2. Okay, so well, we can start to think about what could be actually the useful things that can further help more students, right? Then comes the idea, because I know students always read this, you're my professor, right? I guess many of you also use me because you read that. Okay, so if you're actually satisfied with the way I teach, if you think that the way I teach helps your study, okay, please go to later. Write something. But no matter what you write, make sure you say, follow the lead earlier. It's very important. Okay, I really wish that I don't mind that I spend more time to talk to students. Okay, I remember I told everybody that my main job at University of Houston is doing research. Okay, so I write a lot of papers. Okay, and that's my main thing. Majority of time should be spent on that. Okay, teaching is actually something kind of like for fun. Most of my time they don't think this is actually a fun job, especially teaching this service course where you're going to have 400 kids, 400 students or 500 students, right? They feel like this is actually a tiring job to do, wasting our time. Okay, I don't think so. Okay, I do feel like if we want to actually make the society improve, we do need to make the young generation understand things better. Okay, so I would suggest, I would actually encourage you to actually say something on the real professors, okay, which we can pick up more students in the future. All right. So with that, I wish everybody the best for your future and good luck with your final exams. Thank you.
Thank you.